Welcome to LNP Renewable System Integrator. Today we are going to discuss about the ship automation basics part 18 of 22. If you have missed part 1 to 17, please subscribe to our channel. In our channel, we have created a playlist named Ship Automation Basics part 1 to 22 English, so that whatever thing that you missed out, you can check there. Next, in the part 18, we are going to discuss regarding the how process metering is done. What are the sensors that we are using in practice? So mostly, okay, we might have a doubt how some of the sensors looks like. Okay, so at the end of this session, okay, we will find the answer for the following question. That is how a PT100 RTD, that is the temperature sensor, looks like. How we need to do the wiring. How a solid state thermostat looks like, and what are the international color codes for extension cables, and what are the different types of thermocouples available in the market. How a converter looks like, how to measure a resistance across the resistance terminal, how a pressure transducer looks like, how a speed sensor looks like, and what are the speed sensor types. Okay, what are the sensor symbol and its output, and how a fuel rack sensor looks like. Okay, so as we told earlier in our discussions, we might be using so many symbols, short forms, and abbreviations to represent the instruments for measurement and indication, circuit breakers, connections, generators and transformers, fuses on the circuit breaker, protection and the monitoring relays, switches, relay and contactors, units and divers. So if you have any doubt, kindly please refer to this. So RTD, that is resistance temperature detector. It means it works on the principle of resistance. Okay, these are wire wound or a thin film devices which measures the temperature by using the physical principle of positive thermal coefficient and the electrical resistance of the metals. So hotter they become, higher the value of the electrical resistance. It means if one element is getting hotter, it means based on the positive thermal coefficient principle, okay, if the heat is happening on the, if the element is feeling a heat, means its electrical resistance increases. It is best suited for, okay, for the metals. Mostly, if you want to measure the temperature for the metals, then it is better to go with this resistance temperature detectors. Mostly we are using platinum, copper and nickel applications. We are using this RTD. Okay, it has a linear resistance to temperature characteristic, and it has the ability to withstand the repeated temperature cycles. Okay, so this is a two-wire connection outline of a PT100. Okay, this is how we need to make a wiring. Okay, and this is an example of a PT100 RTD three-wire outline connection. How we need to make. Next, this is a PT100 RTD four-wire connection outline. This is how we need to make the connection. So as we told earlier, in the high tension lines also, okay, high tension cooling water temperature at the engine inlet, we are using the PT100. So if you had a plan to wire, then this is how we need to wire. This is an example how this PT100 probe, which is getting connected in the high temperature system, looks like. Okay, so this sensor is mostly made up of platinum thread. It is a very high costly one. Okay, so it has a resistance at ice point, that is 100 ohms. Okay, how we can analyze the characteristic? So mostly we used to express this in a formula: R is equal to 100 ohms plus temperature in degrees Celsius into K. K here refers to the sensor constant. Okay, so we will have a sensor constant for typical measuring range. It will differ from 0 to 150 degrees Celsius. So as we told earlier, okay, if your resistance is 100, then it is 0 degrees Celsius. Okay, if your temperature, if your resistance is 103.9, then your temperature is 10 degrees Celsius. Like this, as the resistance increases, the temperature is also increases. It means it is establishing a good linear characteristics. So this is how a solid state thermostat looks like, and this is a thermostat wiring example. So in this one, we used to have a thermocouples with a J junction as well as a K junction. Okay, so mostly what are the metals that we are using for thermocouple is ferrous, that is iron, and copper nickel. So mostly we are using these two metals for creating this thermocouples. So when we get into the table, okay, if this thermocouple sensor is having a J junction, it means if the temperature is 0, then the voltage output, DC voltage output will also be 0. If the temperature is 100 degree, it will be 4,09. Okay. If it is a 200 degrees Celsius, then 814. If it is a 500 degrees Celsius, it will be 2064. And if it is a 750 degrees, it will be 31,24. When you're going for a K junction, the microvolt DC will be 0 degree for 0, 100 degrees Celsius, it will be 5,27. Okay, and for 200 degrees Celsius, it will be 1078. Okay, and for 500 degrees Celsius, it will be 2739, and for 750, it will be 4218. Okay, so as we told earlier, whenever you're making a extension for a thermocouple, you need to be very clear, because since it is working on a positive temperature coefficient principle. Okay, it will be available in the bigger sizes. The length will mostly with the length, different length sizes, it is available in the market. But in certain places, in order to transmit the signal that we are receiving from the thermocouple to the remote location panels, we need extension cables. So for that, we need to follow the extension color codes, especially the international color codes. If you're going for a nickel chromium consonant, okay, it is a TC code, then you need to follow the BIS 1843:1952 standard. Nowadays, there are new more standards which are available, that is IEC 5843:89 mod VS 4937 part 30.93. Okay, if you're going for iron constant, we have the component. The TC code will be J. If you're going for nickel chromium or a nickel aluminum, we need to follow this color code. If you're going for a nicrosyl or nisyl, then you need to follow this insulation color code. If you're going for a copper consonant, you need to follow. If you're going for a copper consonant with a low nickel, then you need to follow this color code. If you're going for a copper or a copper nickel, then you need to follow this color code. So there are different types of thermocouples available in the market. Okay, on what basis we are classifying as different types? Based on the raw material that we are using for creating the thermocouple. Say for example, nickel chromium and copper nickel combination, we have a thermocouple. Okay, because in that one we have a conductors, that is chromal and consonant. So in that one we had a temperature range from minus 200 degrees Celsius to plus 900 degrees Celsius. Okay, mostly in what application we might be using this? We might be using it for oxidizing and inert and vacuum applications. Okay, when you're going for a ferrous copper ion combination, it will be using for vacuum oxidation, reducing and inert gases testing. Okay, if you're going for copper nickel consonant, it is mostly used for sub-zero, corrosive and moist application environment. Okay, whereas nickel chromium or nickel aluminum, if you are using, is completely used for measuring the inert gases. Okay, next, if you are planning for platinum, it is little costly. It is mostly used for oxidizing and inert applications. So this is an example of a temperature measuring device. So its main duty is to convert the temperature into a current or a voltage. Okay, it will has a inbuilt thermocouple. Okay, it will convert the resistance to the required current. The current can be in the form of 4 to 20 milliamps. Nowadays, the same thing which is available as a chip inside the PLC, that is programmable logic controllers. It is normally we used to refer it as a analog current cord. Okay, so its output will be in 4 to 20 milliamps. Apart from 4 to 20 milliamps, sometimes we can convert them into voltages also. But mostly for all the temperature applications, we are using it. We are converting them into 4 to 20 milliamps. Okay, we are converting the resistance to current. So now, if you want to measure a ohms between a 3-wire, okay, PT100. So this is how you need to measure the resistance. Mostly it will be in the range of 112.5 ohms. Okay, so most importantly, we'll have some problems. There will be cause for some of the problem. So what are the common problems which are related to PT100 sensor? Mostly, if the temperature reading is too low, these are the possible causes. One is that it might be short circuit, or the sensor will be too much dirty or too much damp over it. Okay, or sometimes if the wiring is wrong also, that it will show the temperature reading too low. If the temperature is jumping from one range to other immediately swapping, it means there is a bad connection in the loop. If the temperature reading is very much high, it means that some open circuit had happened. It means some cable break had happened. Okay, there is a loose connection. Okay, sometimes the connectors might erode or it might be dirty. Okay, now when you are planning for a exhaust gas temperature monitoring, okay, you will have a man that is a controller. Okay, it will have different sort of cycles, but this is how you need to make your wiring connection, three-wire connection. Next, if you had a plan to measure, okay, thermocouple, okay, with a K junction output with a digital multimeter, so you will, say for example, let us consider a nickel chromium nickel aluminum. Okay, it will have a micro volt DC of 27.5. So as we told earlier, there are some common problems which are related to the thermocouples that we are using in the industry. Mostly if you have a facing any problem, that is the temperature is too low, possible causes will be the short circuit, there will be moisture on the thermocouples, there will be moisture on the connectors. Sometimes positive and negative thermocouples might be switched. Okay, and sometimes these compensation resistors are incorrectly connected. Okay, if it is showing temperature too low, means there is a possibility for open circuit due to the cable break or loose connectors. So as we told earlier, this is how a 4 to 20 milliamps pressure transducer looks like. Okay, it is converting the pressure into 4 to 20 milliamps current. So say for example, if you had a plan to measure 4 to 20 milliamps current in an output signal, so keep in mind voltage you measure across the terminals, whereas the current you need to pressure in the series lines, okay, across 1 and 23, so that you will try to get what is the current, exact current output. Okay, so when you had a plan to measure a 4 to 20 milliamps output signal, this is how you need to connect and check in your multimeter. Nowadays in industry, so many different varieties of transmitters are available. So these are some of the real-time photos of mass transmitter, Danfoss transducer with the inbuilt transmitter. We have a scanner transmitters, we have a LCS 4 to 20 milliamps adapters also. Okay, there are two different types of speed sensors which are available in the market. One is the magnetic pickup type and the other one is the proximity switching probes. Okay, there are so many differences between the operating principles and the troubleshooting approaches, but still these are often used as a speed sensors. So if you want to measure a voltage across a proximity speed switch, so across these terminals you need to measure. So it is converting the speed to a voltage as well as a frequency. So if you measure the voltage, it will be 24 volt DC, and if you measure the frequency, it will be in the range of 645 hertz. Okay, and even in order to control the engine speed, we are using a speed converter. So it will convert the speed into a required current. It can be in a 4 to 20 milliamps, or it can be a voltage, or we can also convert the speed into hertz. Okay, so as we told earlier, there are so many different proximity sensor outputs are available. These are some of the symbols, and what will be the output type we had shown here. We have a normally open type, we have a normally closed type, we have a combination of both normally open and normally closed type. We have a 2-wire non-polarized NO or NC. We have a 3-wire non-polarized NO or NC. We have a NPN type switches. We have 4-wire NO or NC type, PNP or NPN type, and also even we have analog output signal types also available in the industry. The analog output can be either in the 4 to 20 milliamps or 0 to 10 volt DC. So this is an example of a real-time photo of a fuel rack sensor. Okay, it is an inductive proximity sensor with a dual analog output. Either we can take 0 to 10 volt DC or we can take 0 to 20 milliamps output. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. We, LNP Renewable System Limited, we are providing PLC programming training for Siemens, Allen Bradley, and Delta PLCs. We are also providing trainings for ship automation, building management system, building automation control system. If you're really interested to work in the GCC countries like Qatar, Oman, Saudi, Dubai, then you can contact us. We are also providing solar DC lighting systems for the places where EV power is not available. And if you had a plan to establish a electrical fencing for protecting your crops from the animal intrusions, instead of that, you can use the solar fencing as a solution. We are providing solar fencing as a kit. We are also providing solar on-grid, off-grid, hybrid application, solar street solar pump services, design, installation, testing and commissioning, consultancy and training supports. We are also providing access control system basics and also electrical vehicle basics. So you can contact us. We get provided our contact details here. Thank you so much.